Greetings and welcome to another lecture in Introductory Psychology. This one involves motivation, specifically a particular drive called hunger. Now, hunger is something that we all have basically experienced, at least I would hope so. But the thing is, sometimes when we're hungry, we're not physically hungry, we're psychologically hungry. Well, we're going to be talking about the physical hunger that we feel. And basically, we feel hunger when our bodies need fuel. Now, just like I talked about in the prior lecture on the biological theories of motivation, this all revolves around homeostasis. Specifically, it revolves in many ways around how much fuel we have for our brain and our nervous system. Now, the brain and nervous system run on sugar. Some of us have known this for a long time. The rest of the body can run pretty well on partially reconstituted fat, but our brain and nervous system run best on glucose, on sugar. And there is an ideal level of blood sugar that we need to have. That's the homeostasis. If blood sugar falls below that, we begin to starve our nervous system of fuel. It's called hypoglycemia, and it's not good, leads to people getting faint and other symptoms. You can also have too much sugar in your blood. That's called hyperglycemia, and that's not good either. That can cause damage to the kidneys, damage to the eyes, damage to the circulatory system. It's not good. Okay? So we want to keep our blood sugar within that very, very narrow range. And what does that in most people are two hormones sort of working opposite directions. The first one you may have heard of called insulin. Insulin is a very important hormone. It's secreted by the pancreas, and what insulin does is it removes sugar from the blood. Insulin takes sugar out of the blood and puts it into storage, either temporarily as glycogen in the liver and a few other places, or permanently where the sugar is processed and made into fat, which takes a while, but it can be done. Now, insulin, as I said, you may have heard of because it is the basis, or the lack of it rather, is the basis of a disorder called diabetes. Diabetes is when the body either does not produce insulin or it is not receptive to insulin. There's two types of diabetes. Type 1 diabetes is often called juvenile diabetes because it indeed is generally, at least was generally, the type of diabetes you would find in children. In type 1 diabetes, the body, for whatever reason, does not produce enough insulin to help keep the blood sugar in check. It may be because there's a problem with the pancreas. It may have been there from the beginning. It may be a virus or an autoimmune disorder that damages the pancreas, but the body simply cannot make insulin. And so the person, if they hope to survive and thrive, will need to replace the insulin that the body would normally make with man-made insulin. This is where you have people testing their blood sugar many times a day. And if necessary, they will take insulin to bring their blood sugar down, or if the blood sugar is too low, they may eat something. Orange juice, for instance, has a lot of glucose in it, and it can quickly bring blood sugar back up. But it's a balancing act, and it can be very difficult to long-term keep the body's blood sugar in those acceptable ranges. It's why a lot of people these days use insulin pumps that automatically give them the amount of insulin that they need. But those are cumbersome and they're better than nothing. There's actually been some work trying to determine whether or not with the use of stem cells we could regrow the parts of the pancreas that produce insulin in people with type 1 diabetes. But that's very, very preliminary. The other type of diabetes is called type 2 diabetes. It used to be called adult onset diabetes because generally it was only seen in adults, although these days, unfortunately, we're seeing this in children. In the case of type 2 diabetes, it's not that the body is not making insulin. The body is, at least at first. It's more along the lines that because the pancreas is making insulin a lot, the body almost loses its sensitivity to it. Generally, type 2 diabetes is found in people who are overweight or obese. And oftentimes people are overweight or obese in our culture because they eat a lot of sugar. They eat a lot of carbohydrates, particularly simple carbohydrates. And whenever you eat sugar or a simple carbohydrate that is easily converted to sugar, your body's going to release insulin to try to prevent your blood sugar from going too high. If you're constantly eating sugary things, you're constantly going to be releasing insulin. And for a young person, that'll work because a young person's pancreas can keep up with it and the body is still sensitive. But over time, what can happen is either the pancreas may simply begin to wear out. It's producing so much insulin that it just can't keep it up. Or what is more likely, that the body in a way experiences a tolerance for insulin. It's constantly surrounded by high levels of insulin because of the diet. And so therefore the cells that are normally sensitive to insulin lose that sensitivity. And it takes more insulin to get the same effect. Well, there's only so much insulin that you can make. Now, type 2 diabetes is not always treated well with man-made insulin, with shots of insulin, simply because if the problem is that your body has lost its sensitivity to insulin, there's only so much insulin you can flood yourself with. Type 2 diabetes is often treated, and treated very well, by changing the diet. Not eating simple carbohydrates and sugar, which is very difficult because they're very rewarding for us to eat. And trust me, you could find high fructose corn syrup and sugar and glucose in an awful lot of items you wouldn't expect. But if the diet is changed to be mostly meat and vegetables and maybe whole grain carbohydrates, that sort of deal, a lot of times people who are type 2 diabetics not only lose a lot of weight, but they can also wind up with their insulin going back to normal and they're no longer diabetic. Problem, of course, as I said before, is actually sticking to the diet. The vast majority of people who go on a diet don't manage to stick with it, and type 2 diabetes is becoming a real problem these days. We're even seeing type 2 diabetes now in teens as well as children who are even younger. When you have children that are exposed to high amounts of sugar pretty much from birth, they're going to hit that wall faster than people who aren't necessarily. And these days, there is a lot of sugar in everything. At any rate, insulin takes sugar out of the blood, puts it into storage. Its opposite compatriot is glucagon. What glucagon does is it takes sugar out of storage and puts it into the bloodstream. So you can see how these two would balance. One reduces high blood sugar, the other increases low blood sugar to hopefully keep everything in balance. Now, how much fuel we need depends a lot on, well, it's a number of factors, but a lot of them boil down to something called the basal metabolic rate. The basal metabolic rate is how much fuel we burn while at rest. We all know that if you exercise, you're going to burn more energy, but you're always burning energy. Your heart is always beating. Your brain is always thinking. Your nervous system is always having signals sent through it. Your digestive tract is always working. So we're always burning energy. And the basal metabolic rate is how much energy you burn while at rest. Now, someone with a very high basal metabolic rate is going to burn fuel all over the place. And so they are very likely to be thin or require a large amount of food. Those with the slower basal metabolic rate, on the other hand, will wind up not burning as much fuel and will find it very easy to gain weight. Also involved in hunger is a part of the brain called the hypothalamus. Now, the hypothalamus, remember, is involved in the 4 F's, one of which is feeding. And there is indeed a part of the hypothalamus that if it's damaged in a rat, you will have a rat that will eat until it looks like a softball covered with rat. Okay, a rat that swallowed a softball might be a better way to put it. There's another part of the hypothalamus that if damaged, you will have a rat that will not eat until it almost starves to death. Now, we don't think that human obesity really has a whole lot to do with this part of the hypothalamus. What it may have to do with, I'll talk about in my next lecture about the psychology of hunger. Now, whenever you're talking about hunger and burning fuel and everything, people start talking about gaining and losing weight. In the United States, basically more people are overweight and obese than are of normal weight. This is a relatively recent phenomenon, and it's something that people are very worried about because we not only get an increase in diabetes, increase in heart disease, increase in all sorts of nasty things that occur because of this overweight. So whenever you're talking about gaining or losing weight, you also need to talk about something called the set point. The set point is your body's homeostatic weight level. The set point is how much your body thinks you should weigh. Not how much you think you should weigh or your doctor thinks you should weigh or society thinks you should weigh. It's how much your body thinks you should weigh. And because it is a homeostatic set point, it works very much like body temperature and like hunger, which means that if you go on a diet and your weight starts to fall below that set point, your body is going to work desperately to get you back up to it. Okay? Your body is going to think, for instance, that there's a famine and you're starving to death. And therefore, it's going to do whatever it can to keep you alive. It's going to reduce your basal metabolic rate, which is why people on diets are often tired and cold all the time. It's also going to increase your feelings of hunger. And when you take somebody and you make them tired and cold and starving all the time, you can see why diets don't necessarily work very well. On the other hand, it can also work in the other direction. If the person is at their set point and they wind up consuming too many calories and their weight goes above it, it is indeed possible that the body is going to then increase the basal metabolic rate and decrease feelings of hunger. The problem is that doesn't usually happen, because in our evolutionary history, lack of food was pretty much constant. We here in the U.S. who have enough to eat, and other places of course as well, are very, very lucky, but it's very, very rare in the history of our species that this has been so. It's much more likely that we go for long periods of time without food. So what our bodies are geared to do is to gain weight at the slightest opportunity, because you never know when the famine's going to come. You never know when winter is going to be here and there's not going to be a lot of food around and you're going to live off your stored fat for a while. And so therefore, even though most of us in our culture may not really have to worry about where our next meal is coming from, our bodies are still terrified about starving to death. And our bodies will do whatever they can in order to keep us alive. And there's not a whole lot we can do about it until we figure out a way to reprogram that which has been bred into us for thousands, millions of years. There really is not a whole lot we can do about that, except perhaps try not to get fat in the first place. And realize that if you do need to lose weight, it's not going to be something that you do for just a few days or a few weeks or even a few months. Generally, in order to successfully lose weight, a person needs to change their diet permanently. And many of us simply aren't quite ready to go there or to be there.